Hello, students! After learning about atoms, ions, and the very important concept of valency, today we will take the next logical step. We are going to learn how to write the language of chemistry. So in today's session, we will cover these 5 topics in a step-by-step manner. We will start with the basics of chemical formulas and build our knowledge all the way up to calculating mass. All right, let's begin with our first section. You can think of this as learning the basic grammar of chemistry. Think about something very common, like water, or even the salt that we use at home. How do chemists represent their exact composition in a short, symbolic way that everyone can understand? Well, the answer to that is the chemical formula. It's like a code that tells us exactly which elements have combined and in what ratio to form a substance. It gives us a complete picture. Now, the most important thing to remember is that to write these formula, we must know the valency of the elements. Valency, as you know, is their combining capacity. Okay, let's move to our next section. Here, we will learn a very simple step-by-step method to write these chemical formula. We will follow these 4 simple rules. The most important part is step 3, the crisscross step, which we are going to practice right now. Okay, let's take our first example, aluminum oxide. First, according to the rules, we write the symbols Al and O, and then, right below them, their respective valencies, which are 3 and 2. And now, we do the crisscross. The valency number from aluminium, which is 3, goes to oxygen, and the 2 from oxygen goes to aluminium, and these numbers become the subscripts. And this gives us the final, correct formula for aluminum oxide, which is Al2O3. You see, it is that simple. Now, a very important rule to remember is simplification. For calcium oxide, the valencies for both are 2. So after we crisscross, we get Ca2O2. But we must simplify this to the simplest ratio, which is CaO. Now, let's see how we can apply this when we are working with groups of atoms that act as a single unit. These groups of atoms are called polyatomic ions. They behave just like a single ion, so we must treat the entire group as one single entity when we write the formulas. So here is a very crucial point. If the subscript for a polyatomic ion is more than 1, you must enclose the ion in brackets. For calcium hydroxide, CaOH2, the subscript 2 applies to both oxygen and hydrogen. But for sodium hydroxide, NaOH, the subscript is only 1, so brackets are not needed. Very good. Now that we know how to write a formula, let's learn how to calculate its mass. The molecular mass is simply the total mass of one molecule. And to find it, we just add up the atomic masses of all the atoms that are present in its formula. Let's try to calculate the molecular mass for nitric acid, HNO3. To do this, first we need the atomic masses of each element which is involved in the formula. Now, let's look at how we assemble this. We have 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atoms. So we will add their masses together, which gives us a total of 63U. All right, let's move to our final concept for today. This is very similar to molecular mass, but we use it in a specific situation. For substances that are made of ions, like sodium chloride, that is, table salt, we use the term formula unit mass. So what is the difference then? Well, the key is really just in the name. We use molecular mass for molecules and formula unit mass for ionic compounds. However, and this is the important part, the calculation process is exactly the same. And this shows us the logical flow we have learned today. Knowing the valency allows you to write the correct formula, and the formula then allows you to calculate the mass. By following these steps patiently, you can solve any problem on this topic. Please practice this sequence, and you will be very well prepared. Keep learning.